Hello, today we will discuss dry milling of cereals. My name is Kumar Mukherjee, Assistant Professor, Department of Food Technology, Haldia Institute of Technology. Cereal grains, there are different types of cereal grains: wheat, rice, maize, oat, rye, barley. Many are millets. Nowadays, millets are also included into the cereal class. Cereals are mostly they are members of Grassy family, Graminia family, and these are seasonal crops. They provide lot of carbohydrate and energy source. That is why cereal grains are staple food for human. Huge quantity of cereals we consume every day along with other substances. So first such component which is abundant in cereal is carbohydrate. Second is the different proteins. The proteins of cereals are mainly of four types. Uh, One is prolamine, which is soluble in 70% alcohol. Glutamine, which is soluble in dilute acid or alkali. Uh, Albumin, water soluble, and globulin, which is neutral salt soluble. Structure of cereal grains. The common structure is that there is a outer husk portion of the cereal followed by a bran, and inside there is endosperm. So this bran layer is around 14% commonly because different cereals and the composition of this bran layer, percentage of this bran layer, endosperm layer are different. But commonly this is around 14%. Fiber, vitamins, calcium, iron are there in this bran. The higher the bran content within the cereal, the greater will be the mineral content, as content, and bran portion also contain very high percentage of lipid. The bran and germ contain higher lipid percentage, and that is when once milling is done, the byproduct, bran byproduct, is sold differently to millers who extract the oil, rice bran oil, uh, this corn germ oil, etc. Those are very important, and those byproducts are utilized. They have economical value. Endosperm is around 84%, which is mainly starchy, containing protein also, and some vitamin. The ash content in the endosperm is low, so as the endosperm, more and more endosperm come into the flour, wheat, for example, wheat flour, the greater will be the starch portion and lower will be the this ash portion. Germ is 2%, protein, fat, vitamin B and E, iron, etc. are present in cereals. Common wheat variety, wheat is consumed throughout the world, is the first such cereal grains consumed at a greater amount. Botanical name of wheat is Triticum aestivum. The wheat grain having a crease, and once the outer portion, husk portion is removed, this is the bran actually, and this crease is there, and germ is present inside endosperm. The bran portion actually, the innermost portion is alluron, which is adhered to the endosperm, and successively, if we go outside, there will be nucellar portion, testa, tube cells, endosperm, and finally the epidermis. The bran actually protects the grain from outside atmosphere as well as from microorganisms and insects. Average composition of wheat: protein is 12%. In wheat, the predominant protein is prolamine, fat is 2%, carbohydrate about 72%, vitamin 1%, B vitamin and E, pantothenic acid, niacin, riboflavin, etc. are there. 1% calcium and iron, and water actually 12%. The moisture of cereal grains is around 12 to 4% when it goes to the mill for milling purposes, and those are stored at that moisture content. However, harvested at a higher moisture content like 20 to 25%. After harvesting, the first such post-harvest operation which is done, that is the cleaning of the grain, followed by drying operation. And to after drying, the moisture content is brought down to 12 to 14%. That moisture is common not only for wheat grain but also for other grains. Nutritive value, protein having low biological value, gluten in wheat and rye, fat, polyunsaturated fatty acid, essential fatty acid, etc. However, once it is meat, the polyunsaturated fatty acid content is lower because bran portion contains those fatty acid, the lipid portion, bran and jar. Carbohydrate, starch, mostly the rest of the fiber, vitamin B, especially B1 and B2, niacin, as I have stated earlier, also vitamin E, etc. Minerals, calcium, iron, phosphorus, low in water, therefore they keep well. Actually, that is why the grain is dried, because this grain, if it is there is a high moisture content, there is a chance of molds, particularly the molds, they can grow and they germinate and produce aflatoxin. A very common aflatoxin produced by the mold is deoxynivalenol, which is also called DON. And since the cereal grains are not thermally processed, uh, the once it is contaminated by the microbes, it is very difficult to remove those microbes from the milled food material, milled grains. Dietetic value, important energy food because of starch, that is energy food. This is the energy food. Whole grains good for fiber. Whole grains good source vitamin B, calcium, iron, etc. Fibers are there, but the degree of milling, uh, if the milling is extensive, the fiber quantity is also lower. Unsaturated fat is good in low cholesterol diets, cheap and versatile. Coeliacs must avoid wheat, celiac disease, wheat, oat, barley, rye because of gluten. Phytates in cereals inhibit calcium and iron absorption. Polystyrene lacks vitamin B and maize lacks tryptophan, so deficiency uh, decreases can occur where they are in the staple food. In common, cereal grains lack in lysine, the essential one such essential amino acid. They lack in lysine, and lysine can be compensated by consuming pulse and other food materials. Effects of heat on cereal, that is very much important. Nowhere during the milling process heat treatment is done. Very extensive treatment is done because moisture and heat, and there is starch. Starch will gelatinize. Gelatinized starch is completely different, and the process is also irreversible. Once the starch is gelatinized, it is no longer useful for bakery industries. The flour is no longer useful for bakery industries to produce different leavened products like bread, etc. So heat treatment brings about that type of changes. Dry heat also harmful. Grains swell and burst and absorb fat. The milling of grains are done for different purposes. For example, the paddy is milled as a whole grain and it is also consumed as a whole grain after cooking. But wheat is commonly subjected to a milling operation to produce wheat flour. Corn also is subjected to milling to grind the grain and to produce flour. There are different types of uses, and depending upon the end use, the material, the milling is done. For example, the requirement of starch, pure starch from a grain, and requirement of protein from a grain can be fulfilled by a wet milling operation. Cellulose gets soft, starch becomes digestible, protein coagulates. For example, sets dough in oven, protein coagulation takes place. Dextrinization and caramelization causes surface browning on bread and cakes. That is very common thing because protein is present and the glutenin and gliadin portion, the these two proteins, that is prolamine and glutenin, these two proteins, they interact together to produce gluten. Now gluten at a high temperature inside the baking oven coagulates after the fermentation is over, and the gases which accumulated can increase the volume of the bakery material, and then after protein coagulation a cage like structure is produced which restores that volume, final volume of the product. Dextrinization and caramelization causes surface burn because some amount of free sugar is always there within the flour endosperm. Added sugar is there in the bakery material that undergo caramelization and dextrinization. The starch dextrinization takes place, and a color development, that is crust and crumb color for the bread. For cake, high quantity of sugar is added, so darkening of color takes place. Loss of some vitamin is also evident. Types of milling: dry milling, wet milling. Commonly, milling are of two types. One is dry milling, another is wet milling. Purposes are different. Mostly, the wet milling is done to separate starch from the protein fraction. So, when we require a pure cereal starch, for example, corn starch, wheat starch, we do a wet milling operation. Also, wet milling is done when the grain hardness is very high and the grain cannot be ground to a fine powdery mass. Wet milling is preferable. Dry milling, on the other hand, produces a flour with protein and starch portion mixed together. For example, wheat flour is produced by dry milling, while corn starch and corn protein, corn gluten meal is produced by wet milling process. Objectives of milling: common objectives for both dry and wet milling operation. Number one, producing a product with undesirable parts removed from the grain. So undesirable section part is removed. Product suitable for application by the end user. Uh, for example, a bakery industry produces biscuit and another industry produces bread. So according to their requirement, that means the wheat flour containing different quantity of protein, the miller supplies that type of flour. A bread is prepared from high protein wheat flour, while biscuit is prepared from comparatively lower protein content flour. So these two different types of flours are supplied by the industry, and milling is also done following those techniques to produce by blending two or three different wheat varieties having variable protein content, mixing them first and then doing a dry milling operation. So suitable for application by the end user, a product is produced by milling. Increasing value, that means a grain natural after harvesting, the grain having some value, but once the product, milk product is produced and undesirable part is removed, the value increases. Increase bulk mass of the desired part of the grain. Definitely the mass increases, required portion by separating the undesirable part, the required portion, its bulk mass increases, lowering space requirement for storage and enhancing shelf life. Types of wheats. One is spring wheat, very common, winter wheat. Third one is durum wheat. Durum wheat is actually very hard variety of wheat, Triticum durum, and it cannot be utilized by the miller to produce wheat flour because the grain size is so big. Commonly, the wheat flour has a grain size of less than 100 micron or so, commonly 80 micron or less. But in case of durum wheat, to break down to that level, the kernel, it requires very high amount of energy, and the product is always a semolina type product. So durum wheat is commonly used for pasta manufacture. Winter wheat variety, it is also it is sown in autumn and harvested late summer. Winter, there are two varieties among them, each of them. One is soft variety and hard variety. The higher the protein content of the wheat, the harder will be the kernel, while the lower protein content, it will be softer. Flour milling, wheat particularly, dry milling has several stages. The raw material grain comes from the storage, which is pre-cleaned as a post-harvest operation, as I have stated, and then it is dried to 12 to 14% moisture content and stored. From there, once it comes to the mill, further cleaning, the second stage cleaning is done. Different cleaning devices are there. One is the magnetic cleaner. That means a magnet is there where the metals, etc., those are separated. This is the first operation done, because if metals, bigger size pieces of metals are there, it will damage the milling devices at a later stage. Followed by screens, scalper, screen, etc. They separate bigger and smaller size particles, leaves, etc. Then a length ladder or disc cleaner. So successive de-stoner operation, various such cleaning devices, they operate to ultimately keep the grain, to remove the undesirable part and to make the grain free from impurities. Then the next step is the blending operation. Uh, the desired protein content, mostly the protein is important for the bakers who purchase the flour. So protein content can be adjusted by mixing two or three different wheat varieties having varying protein contents. For example, a baker requires 11% protein content flour, and the raw material wheat varieties are one having a 9% protein and another having 13% protein. So in different proportions, these two are mixed together, and then finally the once the product flour is produced, it will have 11% protein content. So blending is necessary for that purpose, followed by the actual milling operation. The After the blending, the material is subjected to a tempering operation, though it is break rolling written here. First of such operation is a tempering operation. This tempering operation can be ambient temperature operation, or at a high temperature tempering can be done. The ambient temperature is 25, and it takes around 18 to 72 hours, long time, while high temperature is 50 degrees centigrade, and it is around 8 to 18 hours time required for optimization of moisture content, equilibrating the moisture content. Why this is done? Firstly, a 2 to 3% after the tempering operation, a 2 to 3% increase in the moisture content takes place, which is finally compensated when milling is over, because that milling process requires extensive abrasion and friction forces. Then that 2 to 3% moisture is removed during that process, and finally the product flour acquires that 12 to 14% moisture level, mostly the 14% moisture level. So that is one such requirement. Secondly, the grain becomes softer and the bran becomes stiffer by this uh, tempering operation. So bran is not fragmented during milling. If the bran is fragmented into smaller size particles, then separation of that bran portion becomes very difficult, because there is no such way by which a flour particle, which is tiny in nature, can be separated from another tiny particle, bran. So bran separation mostly dependent on this aspiration process, air flowing by blowing air. But if sizes are same, almost the same for flower and the brand, separation becomes difficult. So objective is not to grind the brand, but to keep the brand intact and separating it as a continuous layer. So that tempering operation followed by break roll and reduction roll operation. Here is a diagram of this blending. First of all, receiving hopper, magnet, intake scale, that means how much quantity of this wheat is to be taken is measured, receiving separator, then these are the screens, rejects are there. Then in different silos, storages, different wheat varieties are stored. One having suppose 9% protein content, another 10, another 12, etc. Those are not initially mixed. But when requirement is there for producing a particular type of flour with a defined protein content, then only this blending is done, and then it goes to the cleaning section of the mill. Reduction roll operations can be distinguished from the uh, break roll operation. Break roll and reduction roll. The reduction system and break roll system are different. The break roll is fast. It is around, this is however a break roll system because corrugation is there. The reduction roll and break roll. Reduction roll having corrugation. This is the first such uh, grinding section, breaking section. These break rolls are of 4 to 5 pairs in succession. In between two break roll pairs, there are screens, shifting, separation of different size particle, and purification. That means separation of bran and germ portion from the endosperm portion. So first break roll system, break roll followed by reduction roll. This is a diagram of break roll. There is a corrugation. Now if we look at the corrugation, the this is like this. The cutting edge, this is, if I draw an angle, if I draw a perpendicular line from the base here, this angle is higher, this is around 72 degree, and this angle is smaller, this is around 35 degree or so. Now this side or this side is the cutting edge, this side is the back edge or dull edge. This is called sharp edge, this is dull edge. The dull edge actually gives a compression action while the sharp edge gives a cutting action. Uh, this is the break roll design. Uh, Milling, wheat milling. So break roll pairs fast, where the objective of break roll is not to grind the wheat kernel but to break down the kernel and separate the bran, only to break down the kernel. The smaller the size of the particle in succession when grinding takes place, the higher is the separation of the bran. So bran is not separated at once, it is separated gradually from beginning to the end of the flour milling operation, which include the break roll operation as well as the reduction roll operation. So here these are the break roll pairs. Materials coming goes to sieving operation. The sieves having a large number of sections, and each section having many screens, a large number of screens, followed by this purification stage. Purification stage, it is actually also screen. Purifiers are also screen, but there is air flow system which can separate the lighter particle from the heavier particle. The brands and germs are separated and the heavier endosperm particles are separated from those undesired impurities. Followed by this reduction rule system operation, they are having about 8 to 18 pairs of reduction rules, and followed by the similar sieving and sifting operation. Finally, the flour is separated, flour is produced, and the bran as byproduct and sorts. That means sorts means these are also actually a mixture of chaps, offals, etc., containing little portion of endosperm. Those adhere remain adhered to the bran portion. Those are also impurities. These are separated from the endosperm. Different types of flour depending upon their uh, source, depending upon the equipment which are used for their preparation. Stone ground flour extraction rate is 100% ground between stone. The rate of extraction, it is not related to time like any other velocity or those parameters, but rate of extraction means how much quantity of total wheat grain is taken as flour by milling and how much quantity is separated. This, if I say 100% is the extraction rate, that means suppose from 1 ton of wheat grain, I am taking 1 ton of material. I am not rejecting anything. For example, whole wheat atta is 100% extraction. Whole grain is 100%, wheat eaten brown 85%. These are different types. So, however, the flour type is actually judged by the amount of endosperm portion taken. If I collect 40% of total 100% wheat grain, and in another case I am collecting 60%, then the former flour will be whiter than the latter because much of the brand etc are separated in the former case, where those are added in the second case. So darkness of the flour, latter flour will be higher than the former, and first one will be better grade flour. So in this way we can distinguish flour as patent flour, cut-off flour, uh, clear flour, etc. Clear flour, however, the name is suggests it is a clear flour. It is actually the most unclear flour because the rate of extraction is about 72 to 75%. In this case, in case of patent flour, it is about 40 to 45%, and in case of cut-off flour, it is up to 65%. So cut-off flour having the medium quality, the patent flour is the highest quality, and clear flour is the worst quality among all these varieties, three varieties. Patent flour can also be classified as short patent, long patent, etc. A baker's patent flour, a baker's patent flour is patent flour plus different percentage of clear flour mixed together. Whole grain effect of processing. Whole grain flour has more protein than white flour. Certainly because the protein of the bran and jar are included into the flour, while in case of this wheat flour separated by this conventional means, and the bran and this jar portion separated, then definitely the protein content becomes lower. White has no fiber. Definitely because fiber is contributed by the bran and jar. Fibers are hemicellulose, cellulose, etc. Those remain in the bran portion and in the jar portion. White flour has no fat, therefore keeps for longer time. White flour is fortified with calcium and vitamin B. Two operations on flour are done. One is bleaching and another is aging. After the milling is over, a flour can be bleached, and by the action of bleaching, the pH of the flour is lowered. But not all flowers are bleached. The flowers which require a pH of 4.5 or so, less than 5, uh, for example, in the cake manufacture, which discourages the gluten formation, in that case only bleaching is done. Chlorine gas is the agent, and chlorine mixes with the water present within the flower to produce hydrogen chloride, and this hydrogen chloride acid action lowers the pH and hinders the gluten formation. This uh, aging operation, which is storage under definite conditions, atmospheric condition, where the moisture equilibrates and the flower becomes more valuable. So this aging process is also done in case of wheat flour production. The more processing, the softer is the texture. Bleaching agents are used to whiten, as I have stated. Elasticity of the gluten is increased by adding improvers. White flour rises better than whole grain because of that ash content in the whole grain. The higher the ash content, lesser is the tendency of flour to leaven. Leavening means in the presence of yeast by fermentation or by chemical leavening agents like bicarbonate, etc., raising of the flour dough, that is called the leavening action. Cereal products, wheat, flour, semolina, pasta, wheat, babix, and other breakfast cereal, ground rice, rice flour, rice wine, rice cakes, rice krispies, rice peppers, etc. Maize corn, corn on cob, sweet corn, maize meal, corn flour, corn oil, popcorn, corn flakes, oats, oatmeal, pinhead oats, rolled oats for porridge and muesli, uh, oatmeal biscuit, etc. Typically, oat is the cereal grain which does not contain very high percentage of prolamine, the alcohol 70% alcohol soluble protein. Unlike that wheat flour, it contains very high percentage of uh, albumin and globulin. This protein, the albumin and globulin, it predominates, and that is why oat is a typical material by which the oat flour cannot be used for production of leavening product manufacture. Rye bread, crisp bread, whiskey, etc. The fermentation process by this. Barley, barley water. Barley is the raw material for alcoholic fermentation for production of beer, ethanol, followed by ethanol. So barley is another such cereal, very important cereal. Pasta. Pasta is commonly prepared from durum wheat, rough endosperm, semolina. The definition is such that the particles of ground wheat, durum wheat, which will pass through a number 20 screen, but only 2% or less will pass through a 100 mesh screen, US screen. That is the definition of the semolina. Different types of pasta like vermicelli, macaroni, etc. Those are produced using this durum wheat, made in shapes, sold fresh and dried. These are the diagram of this pasta. Different types of pasta are available. Breakfast cereal, wide variety of breakfast cereal. Corn is a very important cereal. Corn flake, etc. Those can be, those are very popular breakfast cereal product. Rice, on the other hand, it is not milled to a powder, but rice is milled to separate the husk portion and bran portion, and also the jar portion, followed by a whitening operation, followed by a polishing operation. So first husk separation, then The brown rice is subjected to whitening operation, and once the bran is separated, then a polishing operation to smoothen the surface of the grain. The rice varieties are of two types. One is raw rice, another is parboiled rice. Parboiling is a different process by which the physicochemical changes of the rice take place, and parboiling is done on the whole paddy, that means husk intact, uh, then followed by milling. Both varieties are subjected to milling. Short grain variety for rice: Carolina pearl pudding used in milk pudding. Medium grain Italian Arborio used in risotto. Long grain Patna, Basmati, etc. Those varieties are very popular in India, used with curry and other dishes. Brown, only some bran removed, nutritious, used like long grain but takes 45 minutes to cook. By parboiling, the cooking time, however, that is increased, and the raw rice is cooked quickly. However, there is enormous loss of soluble material and starch within the glue in case of raw rice. Nutritional, the nutritious components like vitamins, water soluble vitamins, those are actually wasted if you remove the glue of the rice. But in case of parboiled rice, little leaching is there because the surface is sealed, and this removal of this portion of starchy portion and soluble water soluble nutrients removal becomes difficult in case of parboiled rice. So again, these different cereals